All right, let's do some calculus with some exponentials, two of our favorite things mixed all together in one. So we're going to find and classify the stationary points of this expression, and we're going to attempt to do this without a calculator. Ooh. So anyway, yeah, most of you notice when we say calculus, that probably means you're going to do it without your calculator. Yeah, a lot of good that calculus is doing us, right? Don't get to use our calculator anymore. Anyway, well, for this example, we are going to be looking at this function. To be honest, I have no idea what this function, well, now I do because I just graphed it on my calculator. It looks like this. Yeah, I never would have figured that out. So we're going to go ahead and see if we can find and classify any stationary points here. So let's, in order to find stationary points, remember stationary points occur where the derivative is 0. So that's a maximum, a minimum, or a horizontal inflection. All right, so let's take the derivative. This definitely looks like a product to me, so I'm going to say that u equals x minus 2, v equals e to the x. So u prime will equal 1, and v prime, of course, the derivative of e to the x is e to the x. And so I'm going to go y prime equals uv prime plus vu prime. So u, so x minus 2 times e to the x plus v, which is e to the x, times u prime, which is 1. All right, now from here, we have to figure out how to get the derivative equal to 0. So we're going to say 0 equals x minus 2 times e to the x plus e to the x. All right, I'm going to go ahead and subtract e to the x. So I'm going to have a negative e to the x equals x minus 2 e to the x. I'm actually going to divide both sides by e to the x. But can you do it, Mr. Bywater? Yes, you can do that because x, e to the x won't ever be 0, right? An exponential can't be 0. No matter what x is, this value can never be 0, so you're not actually dividing by 0. And in fact, you won't actually lose any solutions either because you're not doing something that's illegal. So if we divide both sides by e to the x, then we'll get negative 1 equals x minus 2. And if I add the 2 to both sides, then I get at 1 equals x. That is my stationary point. So if I were to classify this, I would at x equals 1. Now I need to do a sign diagram. So I'll go ahead and plug in some values to my derivative up here. So let's put in 0 because 0 is easy to work with. So if I put in 0 minus 2, so 0 minus 2 times e to the 0 plus e to the 0, and I find out that this, if I go there, that would be negative 2 plus 1 because this is 1, right? So negative 2 times 1 is negative 2 plus 1. So I got a negative number when I put in 0 for x into the derivative function. So therefore, I'm going to say anything here is negative, anything here is positive, which makes this the derivative. This is, remember, this is for the derivative function, which means I'm looking at the slope. So my original function is going down, then my function is going up, which means at x equals 1, there is a minimum. Don't believe me? We'll go back to the graph right here, which if you look at my y equals, just to double check, see, there you go, there's the function, that's the same thing that we have there. And when we graph it, we do see a minimum. We can do second calc, again, and we can go minimum, and it's between here and there, and guess, and we get our minimum at x equals 1. So there you go. We found and classified the stationary points by using calculus. No calculator. Cheers. Have fun.